Hi, I'm Ethan Jewett. I'm from Mindset Consulting, and today we're going to talk a little bit about how to make the most of BTP and hyperscalers, and specifically with reference to joint reference architectures, which not a lot of people have heard about. They've been around for about a year now, but it's a really important topic around how to integrate BTP with your hyperscaler, and I'm really looking forward to talking about it today. So let's get started. Um, what we're going to hit on today is just a foundational kind of discussion about what joint reference architectures are and really what the role of architecture is in an organization. Then we'll look at a few examples of joint reference architectures and talk a little bit about where to find more. And then maybe the kind of the really meat of the discussion is, what do you do with these architectures, with these joint reference architectures once you've got them? So we'll spend a little bit of time talking about that. So with that, let's jump in and talk a little bit about the foundation of joint reference architectures. Basically, we're going to talk about the what and the why of joint reference architectures for BTP, why they exist and what they are. So let's get started. So like I said, first I want to talk a little bit about the role of architecture itself. And I think this is a really important topic. It's one that I really feel very strongly about. I think that architecture has a huge and important role in the types of applications that we build, the types of technology projects that we do at Mindset and our customers. And yeah, I'd like to talk a little bit about that. So in my view, the role architecture has four different roles. The first is to create a framework for value delivery so that everyone in the organization can be aligned on what the objectives are that we're trying to accomplish. And that means everybody from like stakeholders and people who are paying for the projects, all the way down to developers and testers, and the end users who are actually going to be using the application or the technology that's being developed. Secondly, alignment of those stakeholders, right? So a lot of the time we see on projects or at customers where we're trying to go through an initiative and get something done, but different people in the organization have different ideas about what's happening here. And maybe they don't agree, maybe they are just focusing on different things, but architecture can really provide a framework so that every person in the organization, every stakeholder has a way of looking at the project that is aligned and that allows them to have a coherent view together of what we're trying to accomplish. So along those lines, and you've probably gathered, a lot of what's going on here is really communication, and that architecture itself is a means of communicating. It's really focused on creating different views of the application, of the IT landscape, of our business strategy from different perspectives, so that different people can communicate about it, can talk to those different artifacts, and have a way of talking with each other, even if they don't share a lot of the same vocabulary, tools, all that stuff. Architecture tries to help create that common vocabulary. And then lastly, verification. So once something's actually built and done, a lot of the time stakeholders will have a question, well, how do I know this is actually working? How do I know this is actually built in the way that it's supposed to be? And again, the architecture can serve as a way to come back to the architecture and say, this is my understanding based on the architecture of how this was supposed to be built and how it's supposed to work. And there are ways that I can verify that. I can look at what's been delivered and see if it aligns with the architecture. So this role of architecture as a unifying framework, as a communicating framework, I think is incredibly important. Most of the architecture frameworks that we use in the SAP world are based on one of the big sort of enterprise architecture frameworks, or at least inspired by them. So for example, the Zachman framework is where this idea of different perspectives come from. And the Zachman framework is very interested in creating artifacts that match every perspective at every level, and basically creating a matrix of artifacts so that for every person with every perspective in the organization, they have a way of interacting with the architecture and understanding the architecture. the open group architecture framework is a bit of a different approach. And, and although it ends up creating a lot of the same types of artifacts, but it's very focused on defining the thing that's being delivered at several different levels of abstraction that more or less match up to different stakeholders in the organization. So there's a lot of criticism of these big architecture frameworks. They're too big. They create outputs that are really not fit to purpose. Sometimes there are criticisms that I think may often be valid, that these types of frameworks actually result in recommendations because of the structure that they impose that just are incorrect and that often get ignored in organizations. So this is where sort of real architecture comes into the picture. The App House, the SAP App House, has developed this concept of architecture thinking, which is based on lean architecture, which itself is based on TOGAF, the Open Group Architecture Framework. And each of these frameworks sort of strip it down to something that is really useful. At Mindset, we take the lean architecture framework and we apply the concept of minimum viable architecture. So this is really helpful because it really just breaks it down to a few specific artifacts that really have to be delivered for all of our projects. And all the other artifacts can be really useful, but sometimes they're not fit to purpose. So we need to be very picky about when we actually implement one of those artifacts and make sure that it really is providing value. So just to talk about this a little bit, minimum viable architecture, it focuses on the application architecture domain. So this is something that is part of TOGAF, where there are 4 different domains. There's application architecture, data architecture, technology architecture. And this focuses on the application architecture area. So it's pretty focused on realizing applications. And again, each step along the way provides a lower level view. So again, this is based on TOGAF. So it's very much based on this sort of hierarchical view of the architecture and of the organization. And we start with, in minimum viable architecture, we're really focused on the technical architecture piece oftentimes. And that oftentimes will start with the context. And the context provides the business context and functions that are related to the solution. So it's not focused on what technologies we're using, or even necessarily like the specifics of workflows or anything like that. It's focused on the business context and the functions related to the solution. So things like we need a journal entry management system. We need the ability to have workflow with approvals. These are functions that are important for the business, where we need to have an approval process, for example. So the business process level. Next up comes the concept, or the concept diagram. And this is the first sort of technical conceptual approach to the solution. So for each of those context business capabilities, what is the corresponding technical solution that needs to be provided? So if the business needs approvals, then from a technical solution perspective, we need a workflow engine. If the business needs a journal entry management system, from a technical perspective, we're going to need an application that the user can access. We're going to need some sort of data store to manage the journals, and we're going to need a business rules engine to deal with the rules that we have. But we don't focus on specific technologies. We're not focused on using BTP or using S4 or using Java or something like that. Lastly, at the level of detail where oftentimes development teams get involved, we have the solution realization diagram. And this focuses on the specific technical implementation details. So here is where we say we're using Fiori in UI5, we're using BTP workflow management, and so on. So these are sort of the levels of architecture and what they're doing. And just keeping this in mind, like, this helps to answer some of these questions about what type of alignment do I need? How do I communicate the way that we're going to be using that we're going to be implementing this application or the set of applications? How do I verify that it's been done correctly? All that stuff is really important, and architecture helps to answer those questions and make it real to a lot of the different stakeholders. So with that, we can talk a little bit now, we can start to talk a little bit now about joint reference architectures. Because these answer questions that often arise in organizations around how do I make my hyperscalers and my BTP work together? That's the main question. And I think a lot of different stakeholders in a lot of different parts of the organization have different views on this. These result in a bunch of different problems, right? So SAP customers, almost all SAP customers are using some hyperscaler resources, AWS, Azure, GCP, right? SAP, one stakeholder, one point of view, makes some recommendations that most of their customers should use BTP. That's what SAP wants people to do. And of course, because customers are all using, and we use, of course, hyperscalers as well, there's going to be a need for interoperability there. There's also a significant overlap in functionality between BTP and the hyperscalers, right? So if I need a workflow engine, well, do I use the BTP workflow engine or do I use the hyperscaler workflow engine? If I need an event broker and event management, do I use the BTP one or the hyperscaler one? API management, same thing. So there's a lot of overlap, and this creates a question, and it creates a lot of different views from different stakeholders in the organization around what the answer to that question should be. And the question is usually BTP or hyperscaler. And we'll have SAP saying use BTP. We'll have the SAP group within the organization sometimes saying use BTP. We'll have another group that is oftentimes responsible for the hyperscaler saying use the hyperscaler. And we need to figure out a way to come to a conclusion there. So these are some of the problems. And there will be a set of questions that come out of those problems, which we've already mostly covered. But again, for a given workload, what do I use? If I need to use both of them, how do I manage and scale interoperability between them? So we need an architecture that describes how to do that. Addressing concerns around security and interoperability is hugely important and is something that we have to develop either as an architecture ourselves or based on one of these joint reference architectures or another type of reference architecture. These are questions that architecture should help to answer. And again, the role of architecture is to answer these questions and alleviate some of the tension between different stakeholders that arises when some of these questions are left unaddressed, right? So we have the conversation, we establish the architecture, we get it agreed to by all the stakeholders, and it provides a way for every stakeholder to engage with it. And then ideally that question is relatively settled, and we also have a framework for coming back and revisiting the question. So again, the joint reference architectures are really nice because we talked a little bit before about the fact that SAP is always going to have a point of view, right? The hyperscalers also have a point of view. They want you to use the hyperscalers, but it's really there's not as much tension there as sometimes it seems. And SAP and the hyperscaler vendors, starting with AWS and now Azure and Google Cloud, work together to develop these joint reference architectures. So these architectures help to answer many of these questions. They do provide a validated approach, which is really nice. And they are co-developed by SAP and hyperscaler partners, which means that they at least have 2 points of view that are aligned within them, to help to give some answers to how to address these problems. Other reference architectures are also available from a bunch of different sources. They're not joint, they're just reference architectures. And those sources include SAP, consulting companies. Mindset has reference architectures. They often will serve the same purpose as the joint reference architectures, and we'll hit on some of the ways to interact with both joint reference architectures and non-joint reference architectures, for lack of a better term, um, towards in the last section of the presentation. So joint reference architectures, generally speaking, the ones from AWS and SAP, but also the ones from Azure and GCP and SAP, they kind of come in three different flavors. They come in a flavor that is about the foundation of the platform. So how do I set up principal propagation, identity propagation between my platforms? How do I create a good foundation for developing apps, for managing data, all that stuff? Then they have a flavor focused on app creation. So how do I create apps well? How do I run a Fiori Launchpad or a work zone? How do I do a portal? Those types of questions, things that users interact with, right? Applications. And then there's a flavor of joint reference architecture that's focused on data and data integration of various types. So these are going to be joint reference architectures that are focused on machine learning, AI, data warehousing, data lakes, and integration scenarios. And we'll hit on kind of one of each of those as we go through this. But before we talk about that, let's talk really quick about what joint reference architectures are not. They are not really usually usable off the shelf by your organization. You are going to need to do some work to adopt them. They don't give you permission to abdicate responsibility of the architecture function, and they're not unbiased, which is the reason why you have to keep that responsibility. And then lastly, they're not perfect. So the question I think that we need to ask ourselves here is, do our organizational objectives and principles align 100% with SAP's and AWS's? No, they don't. We have different priorities. We have different approaches. We want to minimize spend, whereas SAP and AWS would like us to maximize it, surely. And probably the right answer is somewhere in between there. So just keep in mind, SAP and the hyperscalers each have priorities. Joint reference architectures are imperfect negotiated compromises. They are usually good compromises, but they may not be the best for you. And so we need to make sure that we're thinking about how to adapt them to our organization. And again, this is something that we will hit on in the last section of the presentation. So with that, let's jump into a few examples of reference architectures, and then we'll dive into how to sort of adapt one of those to our use case in our organization. So I'll put myself in the corner here, and we'll go look at a couple of these reference architectures. All right. So like I said, we'll have one from each sort of section. This is an architecture that's focused on platform foundation, and it comes from SAP and AWS, obviously. This is an architecture that is talking about, if I have a build work zone, so work zone is the Fiori Launchpad in BTP, so hosted on the cloud. If I have a build work zone, how do I establish business continuity and high availability for that work zone? And this architecture suggests that there is a way to establish that using both BTP and AWS's Route 53 DNS service. It also provides an approach to getting better performance. So you have geo-aware routing of your users. So just as an example, you might have one work zone hosted on AWS Europe and one work zone hosted in AWS Australia. And you want your users that are in Australia or Southeast Asia to be routed to the Australia work zone, and your users in Europe and the US to be routed to the Europe work zone. Of course, if one of those work zones go down, you'll want all the users to go to the other one. And that will result in performance degradation for users who are not on their correct work zone, right? But it'll at least work. So you'll have high availability. And when they're both up, those users will have significantly improved performance because things like the UI5 libraries, and depending on where you're hosting your actual, depending on where you're hosting your actual UI5 applications, the applications themselves will be served from much closer to the end user. And this makes a huge difference. The application loading and library loading is one of the biggest pieces of performance for a work zone site and a Fiori Launchpad. So this is one joint reference architecture of how to approach that. Of course, you can do similar things in Azure and GCP. And in fact, you can even do similar things with on-premise Launchpad using CDNs. An integration app development architecture that is a nice reference architecture is this one around real-time notification. So again, this one's focused on AWS. Looking at using how do we notify people on their mobile device or via email when something happens in the system, when an event happens in the system, right? So this one's focused on using the built-in S4HANA events, the BTP event mesh, and then propagating those events out to AWS's simple notification service in order to publish those notifications to devices. So basically just focused on how do we get multi-channel communication working using the enterprise standard communication framework, right? Because probably if we're in a large enterprise, we already have some capability to do push communication to customers or end users. And that's probably based on a hyperscaler framework or a third-party service like Twilio or something like that. And we would want to have an architecture for leveraging that from our SAP system as well, so that we don't reinvent the wheel. And so that there's sort of one place for people to go to manage their notifications. All right. This one's focused on data and AI, and is the reference architecture that SAP provides around consuming OpenAI services in Azure, so Microsoft's OpenAI APIs, using CAP and SAP's BTP AI core. So just a nice reference architecture showing you what are all the pieces that fit together in order to leverage LLM, a large language model, or other types of machine learning models in our enterprise applications. So it provides model abstraction, it provides high availability, it provides some data privacy management features, and it provides that roadmap for how we go about doing this. Now, of course, there's a way to do this with AWS as well. Maybe not with GPT models, but with the Titan models or the other Bedrock models that AWS provides. And of course, there are ways to do this with GCP using the Vertex model and other models that Google provides. But again, this is a blueprint, a framework for how to go about doing that. Then lastly, and this is the one that we're gonna end up diving into a little more, is an approach to getting value from data, quote. But how do we train hyperscaler machine learning models on SAP data? And the way to do that with this reference architecture that SAP provides with reference to all the hyperscalers is via FedML, which is essentially a database connection back to DataSphere. And then using the hyperscaler machine learning platforms, because that's where the theory is, at least, that our data scientists will be proficient with developing machine learning models. So again, just developing efficient and consistent and cost-effective proprietary models that are trained on our enterprise data. How do we do that? This is one answer. And again, this is not a joint reference architecture. This is a reference architecture that SAP provides. So we're going to talk a little bit about that next, and thinking about how do we break that down? How do we adapt this to our own needs? So let's jump into that discussion. How do we actually use these joint reference architectures? So what do I do? What do I do with my joint reference architectures once I've got them? I think there are four things that we need to really think about when we're looking at a joint reference architecture. or a reference architecture of any type. And the main question here is, again, how do we fit this architecture to our organization? Okay, so it's not going to be a perfect fit usually. We're going to have to make some decisions, some trade-offs. We're going to have to assess whether it fits us and what types of changes might be made based on that. So number one, and this is actually several things, but number one is what we often heard referred to as data gravity. So where does the data reside in our organization? But I don't think it's just about data. Gravity is also about skill, about code base. There are probably other things that you can add to the list, but where is our momentum, our velocity? Where is the bulk of our ability and data and effort focused as an organization? This is gravity. Okay. Second is cost versus time trade-offs. So a lot of this stuff is saying use a service that you need to pay for, and that's the correct architecture. And that's not always correct, right, for organizations. Sometimes it makes sense for us to do it ourselves. Maybe because we're worried about proprietary information, maybe because we just feel like we always have to do things ourselves, which may not always be a really good place to be. Maybe because there's something specific that we need that none of the service-based offerings provide, and we just have to do it ourselves because this is part of our competitive advantage. So this is a trade-off we need to be thinking about for each of the sort of nodes in each of these architectures. Scaling, security, and performance, something we always have to consider. Sometimes these architectures are built for massive scale and we don't need it. Sometimes these architectures are built for smaller scale than we've got, and we need to think about, do we need to do something different? The same for security and the same for performance. Do we have specific security needs that the architecture doesn't meet? Do we have specific performance needs that the architecture doesn't meet? And lastly, the ability to support the next step. So if as an organization we have a solid roadmap in front of us, oftentimes a multi-year roadmap, we oftentimes have some idea of where we need to go next with the infrastructure, the applications we're putting together. Does this architecture support those next steps? So oftentimes we look at the current step we need to take and what the answer is there. But we need to sort of force ourselves to think a little bit further out and think about that next step or the next few steps and whether the architecture supports that. But let's just kind of sit down here and go through this for the ML model that we just talked about. And so I'd like to dive into this a little bit. We've got, again, this ML model with the hyperscaler, and we're going to just get into how do we apply these questions to this ML model. I'll move my head around a little bit. So again, there are the 4 different questions we need to ask ourselves. Gravity. So if we look at this architecture, where is the data gravity for this architecture? And part of this, there's a little bit of a hint in what I said before, is that this architecture comes from SAP. But it's clear to me that in this architecture, the data gravity is on the SAP Business Technology platform in SAP DataSphere. That may very well be the right answer for your organization. But I know that a lot of organizations have their data gravity in the hyperscaler. They're using AWS or Azure or GCP as their data lake and their data warehouse. And so their data gravity is really in the hyperscaler and not in BTP and DataSphere. So whereas this architecture centers DataSphere and says that all data needs to flow into DataSphere and or be federated from hyperscaler data sources, which are portrayed as not as central. If the gravity of your data is actually in the hyperscaler data source, you may need to swap that around and make your hyperscaler data source central, say Google BigQuery, and then federate data from DataSphere. So it really depends on what the central data gravity of your organization is and where the bulk of the data that the ML process is going to be focused on is sitting. Okay. Secondly, skill. This reference architecture makes some assumptions about where skill sits. So the basic assumptions that I see here are that data scientists are going to use Jupyter, and they're going to use it on a hyperscaler ML platform. And the data modelers are going to use Datasphere, and that they're going to be doing their modeling in Datasphere focused on SAP and non-SAP data. Again, this may not be true for your organization. So probably some data modeling needs to happen in Datasphere, but most of your data modelers might be working on BigQuery or Redshift or Snowflake. And if that's the case, you might need to turn this around. Again, you probably do want to leverage the capabilities of Datasphere to extract and apply semantics to SAP data, regardless of whether it's central to your data modeling process or not. But you may push the data on from there into the next level where more modeling happens. If we think about the ability to support the next step, we might be thinking about things like, do we anticipate adding significant IoT data sources in the next 2 years? Does the architecture support this? What do we expect our data volumes are going to look like in the future? Does the architecture support that? So those are the types of questions you'll want to be asking there. And then, like I was saying before, we need to assess cost versus time. So do we prefer to spend time rather than paying for aspects of the architecture? So on the ML platform side, we might be asking questions like, should we use SageMaker, or do we want to build our own ML platform internally using the Python Foundation? It's a common question. Or pull in an open source project that's focused on machine learning and work on that, or pull in a third party like something from the company formerly named RStudio, the name of which I forget, to use to manage our internal data process. So those are all perfectly reasonable questions and could result in swapping out portions of this architecture. Similarly, do we really want to use Datasphere? Do we want to invest in making direct connections to SAP and doing custom data extraction? So that's a question that we should be asking and we should answer. And for some companies, the right answer is going to be use Datasphere. For some companies, the right answer is going to be, we're just going to build direct connections between SAP and BigQuery, for example. And then lastly, if we look at this architecture, especially, it doesn't have anything about security or authentication. So we need to add to it security and authentication infrastructure specific to our environment to answer the question about how authentication is propagated across the environments, for example. And so any company that's adopting this architecture would need to add that to this architecture before finalizing the adoption. How do you ensure that your machine learning models and your data scientists aren't accessing data that they're not allowed to access? A multitude of HR examples come to mind, of course. There's HR data in SAP, and there may very well be HR data in Datasphere. But whether or not people are allowed to look at that data, it's very possible that machine learning models should not be allowed to look at it because there might be data in there and attributes of people in there that we should not be training probabilistic models on, as an example. So that covers most of what I wanted to talk about today. Again, I want to encourage people to take a look at the joint reference architectures. They are available on SAP's websites and also on many of the hyperscaler websites are focused on the areas focused on how to integrate with SAP. And whenever you're doing architecture, again, I think that architecture is incredibly important, and we should be taking an architectural approach to thinking through most of the problems that we have in our organizations. And these joint reference architectures and reference architectures can really help with that in a really big way by giving us a big head start and giving us some really good ideas about how to integrate these different platforms, BTP and the hyperscalers. But we can't just take them as is. We have to take responsibility for adopting them into our own architecture function and making them ours and making them fit our organization. So I want to encourage you all to do that on a regular basis. So thank you. It's been great to talk to you today. Again, I'm Ethan Jewett, Mindset Consulting. You can absolutely get in touch with me if you want to talk about this topic or any other. And thank you for watching.